Alright guys, welcome to chapter 6. This is 6.1. If you haven't grabbed the notes yet, please make sure that you do that. So we're going to start with just the objective or the topic for today. We are going to analyze key characteristics and determine average rate of change for polynomial functions. So we're still looking at functions, same stuff we were doing in chapter 5. We're just going to do a little bit different things with them. You can see that there was a third piece here, and I've took that out. It's not something we're going to talk about today. Okay. So go ahead and look at your notes. In your notes, you guys have space for your warm-up and the graph that goes along with that warm-up. But I would like you to try some of these on your own. So again, pause the video as often as you need to try the problems before I go over them. And I will not be going over as much as I did in chapter 5 because hopefully we are getting better at this. So there's certain things that I will not be going over that you're still responsible for. So first thing, go ahead and pause the video and work on the warm-up. Again, our goal for that warm-up is that you write the function for this graph. When we're writing the function for a graph, first thing we want to do is identify the zeros. If you haven't figured out where those zeros are yet, please go ahead and mark them on your graph. Go ahead and do that. So one at -5, one at 1, and one at 3. And so most of us are pretty good at this. You might not realize that you're good at this, but when we talked about it, we all did very well. After we've got those zeros, that means that that's how many binomials, right? Things in parentheses that we've got. So the first one's at -5. Remember that our sign in our function is going to switch, so it's x plus 5. And we should be checking our multiplicity. Notice that this one is crossing straight through. So our multiplicity is 1. We don't need to write that. There's an invisible 1 there. Next zero is at 1. So we're going to have x, and it's +1, so our sign's switching, -1. And lastly, this one's at 3, so we're going to have x -3. There's something missing. If you haven't identified what that something missing is, please pause the video, take a look at that graph, and figure out what is missing from our function. Look at what's going on at the end over here. It is going down. How do we take care of a graph that is going down? Throw a negative in front. So now we've got a negative function with these 3 zeros. All right, we're going to move into today's lesson. So next in your notes, we're going to take a look at a graph. I'll pull that graph up here in a second so we can talk about it just a little bit. But you're going to answer questions A through H, and I think I'm only going to talk about 2 on this video. Make sure that you're marking those answers on your graph in your notes, and then being prepared to discuss them tomorrow. So we're going to spend the first part of tomorrow talking about this graph. Okay, let me pull that graph up for us. It's this one right here. So for most of the day, this is the graph that we're going to be looking at. What we've got going on is this polynomial function, so I'm reading up here, models the profits for Zorzanza, I don't know, a made-up video game company, for its original business plan through its first few years of business. So if you look at the graph, obviously it's about the profits, the time that they've been in business, and then the amount of money that they've made. Notice this is another one of our no numbers graph. Okay. Question 1 is asking us to label the portions of the graph that model each of the memorable events in the company's history by writing the letter directly on the graph. And then make sure that you also explain. So we're going to do A together just so you can kind of see what I'm looking for. Question A says the chief executive officer, the CEO, right, the person in charge of the company, anxiously meets with her accountant. Now, anxious says certain things to me. It says that the boss of the company, the owner, the head of the company, is nervous about the business. And so if I look over here, as a boss, where would I be nervous about the company? Well, that's going to be when we start losing money, right? So anywhere in here, I'm going to say there's probably an A. I would also hope that after meeting with my accountant, we kind of turn things around. So I put it on the lower end of that. But anywhere in here is where the boss might be nervous. Go ahead and pause and pause the video and try to do the rest of them. So again, it goes A through H. So go ahead and try that. The other one that I want to do together is E. And the reason that I want to do E is because there's kind of this hidden vocab word in here. This breaks even. It's an economic term, but we use it in math as well. This break even means that you have no profit and you also have no debt. Okay, so after you start a company, right? Any break-even point is when we have no profit, we're not positive, but we also have no debt, which would be down here. So any of our break-even points, there's actually 3 on this graph. So right here, here, and here, those are all E. All 3 of those places are where we break even. This is the first time it happens, the second time, and the third time. If you haven't finished labeling your graph for A through H and kind of explaining, right, so make sure you are writing in here why you think that so that you can justify it to me tomorrow without having to redo the whole problem, go ahead and pause and take care of that. Moving on to the second page of your notes, we've got 2 students here that are discussing end behavior, and they come to a disagreement. So I'm going to go ahead and read through those. What I want you to do is summarize each student's thoughts, and then over on the side here, say who you agree with and why. So above each name, summarize their thoughts, and then over here, who do you agree with or disagree with. So the first student there says the end behavior is incorrect. Incorrect. As time increases, profit approaches infinity. This doesn't make sense that the profits are increasing before the company even opens. So again, remember this graph, this is the same graph, is a projection of what's going to happen after they open. And she's saying it's incorrect because we are going up at the end, and so that doesn't make sense. Go ahead and summarize what that student said in your own words right above. Our next student said that the end behavior is correct because the function is cubic with a positive a value, right? Meaning the number in front is positive. This means that as x approaches infinity, y also approaches infinity. So as we go to the right, we're going up. And as x approaches negative infinity, the graph is, y is also approaching negative infinity, so it's going down. Again, summarize what she said right above there. Then I'm going to ask you to take some time and answer this question. Who do you agree with and why? Make sure that you are answering that why part and not just putting a student's name. Which of these 2 students do you believe is correct and why do you think that? Go ahead and pause the video, take some time to do that for me. Alright, we're almost done with the first part of our objective, which was finding key characteristics. This next part, I gave you the same graph, but it has numbers now, and I'm asking these questions. You can see from my highlights the ones we're going to go over. You're still responsible for A and E, so make sure that you're trying those and maybe checking with the partner to see what they said. But we're going to use this graph to estimate when they achieved each profit, and we're going to mark that location on the graph. Let's go ahead and do B together, and then you can go back and do A. So B says, when did we reach $200,000? Notice the profit is in thousands of dollars, and I want to know when it's 200,000, sorry. Well, up here is where 200,000 is. That's happening in a few different places. Here, here, and over here. Okay, so I've marked that on my graph. This is all B. But I also need to be able to explain like when that is. So the first time that that happens is at half a year. The next place that that happens is at about 1.5. And the last place that it happens is it's a little less than 4.5, but so maybe like 2 or 25, so 4.25. Those are the 3 places where they've reached that profit. Okay, go ahead and pause and try to do A, C, D, and E. We'll come back and talk about C and D in a second. All right, C wants to know when our profit is greater than 200,000, and we already kind of did this work over here for that. We already marked 200,000 on our graph. So anywhere it's greater is going to be anywhere where it's above that dotted line we made. So it's happening here, and it's also happening here. Now, being able to write when that is going to be kind of new for some of us. So it starts being greater than 200,000 at half a year. So I'm going to write, and the way that I'm writing this is so that wherever it starts is here and wherever it ends is over here. So it stops being greater than 200,000 at about 1.5. And that's that first part. But then it's happening again. So I'm going to start a new one. And then notice that this graph never stops being bigger than 200,000. It keeps going up forever and ever. So then our time that it's greater than 200,000 is infinity. It's going to keep being greater than 200,000 forever, according to this graph. And that last question then there, where is the company losing money? Well, it's going to be anywhere that it looks like we've got a negative slope. Okay, anywhere where we're going down. So we start losing money here, and we stop losing money here. This whole stretch of time, we are losing money. Again, writing that's going to look a little weird, so it starts at 1. We start losing money at 1 year, and then we stop losing money at about 3.25. Okay, please make sure that you've answered A and E. If you haven't, pause the video and take some time to do that. And we're going to move on to the second part of our objective, which is average rate of change. So here are our notes. This is straight from the PowerPoint, that average rate of change. So in your notes, you've got a blank space for average rate of change. The average rate of change of a function is the ratio of the change of the dependent variable to the change of the independent variable. I say that this is like slope because it is slope. It's slope for a non-straight line. And then I gave us the equation for average rate of change. It's exactly like slope. Change in y over change in x. Exactly the same thing. So on your guys' notes, you should have filled in this blank and the blank that says what it's like. And then for the equation for average rate of change, yes, I want you to have this very technical output for B minus output for A over B minus A, but I also want you to have this change in Y value over change in X, because some of us know it that way, and some of us know this as rise over run, right? That is slope. This is just slope for a non-straight line. So when we go to our first example for determining average rate of change, it wants to know the average rate of change of their profit during this time interval. Now what that's giving us is our X values. This is X1 and this is X2. We are responsible for finding our Y1 and our Y2, and that will almost always be the case. So when we go back up to our graph, at our X1, 3¼ years, we're at about -600. So our Y1 is -600,000, right? Because it's in thousands. Our Y2, we're going to have to go to 4¼ and figure out where approximately our graph is. So at 4¼ are we at 0 there? About 0. Maybe we're up here at 100. This graph is very spread out. There's a huge scale, so of course we might have some margin of error here. I'm going to say that this is about 100,000. Now I know all that I need to know in order to use this average rate of change. The important thing with average rate of change is that your first, these need to line up. Okay, so when I say the output at some X value, it doesn't matter which one I use. I'm going to use this one. And then obviously my other Y value needs to come next. What I mean by they need to line up is this Y value, this Y2, came from X2. So that needs to be the first thing because this was the first thing. And this Y value, Y1, came from X1 over here, so that needs to be the second thing. The actual calculation here is not actually that bad. As long as we remember what happens with negative numbers. So 100,000 minus -600,000, 700,000. If you don't know that, we can use a calculator. That's not a problem. And then 4.25 minus 3.25 is 1. So our answer is 700,000. Dollars, right? Because we're talking about something. So this tells me a few things. Between this year and our second value, so between 3¼ years, 4¼ years, they had about this much change per year. $700,000. Now that's a positive number. That's a good thing as a company. You want your average rate of change to be positive. The way that you can check your sign from here to here, that is a positive slope. We're going uphill. So if I got a negative number down here, we need to be worried. Somewhere, so on a whiteboard or on a separate sheet of paper or something like that, I have the second example in the PowerPoint. It says determine the average rate of change of their profits from 1 year to 3 years. Please go ahead and take a second to do that. I'll come right back and go through that process with you. in case we need some extra help, but I would like you to get just a little bit more practice with that. So go ahead and determine their average rate of change from 1 year to 3 years for me. So the first thing that I'm going to do is I'm going to pick one of these to be x1 and one to be x2. So x1 is going to be 1, x2 is going to be 3, and now I need to find those y values at those places. So over when x equals 1, I'm at about 300. Oops. Y1 is about 300,000. And my y2 is going to come from when x is 3. So I'm going to go over to when it's 3. We're down here at negative 600,000. And then I'm going to use my average rate of change formula. So one of my y values, and it doesn't matter which one, as long as then the first x value I use matches that one. So if I use negative 600,000 as my first value in my y, where my y is, then I better use that same x value. So I'll use negative 600,000 as my first y, and my next one is 300,000. This y value was y2, so I need to make sure I use x2 first. This y value was y1, so I need to make sure I use my x1. And the rest is pretty simple math that we can do in our calculators. So negative 600,000 minus 300,000 is negative 900,000. And 3 minus 1 is 2. So then we have to divide 900,000 divided by 2 when it's negative, so it's going to be negative $450,000, which means that over these 2 years, I'm losing about this much money each year. As like someone who might want to buy stock in this company or get involved in this company in some way, that is not a great number to have. First of all, it's pretty big and it's negative, right? We can see that from the graph. It's going down. So I probably don't want to get involved in this company because not good things have been happening. All right, let's go back over to our notes. Find where we are, please. And the next thing I ask you to do in your notes is to find the average rate of change, but I don't give you a graph. I give you an equation instead. We're going to come back to this example. I'm going to go through one that you can write down or not write down. I'm just going to kind of talk about how we do this average rate of change when you have an equation and not a graph. Okay, so from the PowerPoint, I'm going to do this one first. And so we want to figure out the rate of change of this function between these two. So I'm going to do the same thing that I did before. Identify one of these as my x1 and define one of these as my x2. And just like before, I still need to find my y1 and my y2, but instead of looking at my graph to do that, I'm going to look at the equation. So my y1 is going to happen when I plug my x1 into this function. So I'm going to do 0 squared, because 0 was my x1, minus 4. And 0 squared is 0, minus 4 is my negative 4. And my y2, same idea, but instead of using 0, I'm going to use my x2, which was 3. So I'm going to do 3 squared minus 4. Again, just plugging that x2 into my equation. 3 squared is 9. 9 minus 4 is 5. And there's my y2. So now going to my rate of change equation, we're going to take both of our y values and subtract them. I'm going to do this one backwards of how I have been doing it. So I've been doing with the y2 first. I'm going to just show you that it doesn't matter. So I'll do -4 minus my other y value. And the thing that's important is this -4 happened when we plugged in 0. So the 0 needs to go first. And this 5 happened when we plugged in 3. So my 3 is going to go second. And then I have -4 minus 5, which is -9. And 0 minus 3, which is -3. -9 divided by a -3. If you're not comfortable with your negatives, you should have a calculator in your hand. -9 divided by -3 is +3. That's our rate of change. And I have no units here because this wasn't given to me in any sort of context, so I don't know that it's dollars or anything. Alright, before we do the one in your notes, there's this second problem that you're free to try. I would highly recommend that you try it, and either on a whiteboard or on a separate sheet of paper, and share it with a buddy and make sure that you agree. I'll come back and give you guys the answers to this one, but I won't do all of the work. Okay, so I'm going to show you the answer, but not the work. And then if you can, take another second to do this example. This one is in your notes. Try to do it individually, and I'll show you the work and answer for H and just the answer for G. So go ahead and pause the video, take some time to do that. This is the last thing we're going to do before your DOL, so take some time. Alright, the answer for that middle question there is 3. If you didn't get 3, please ask somebody who did to show you their work, so have some discussion there. If you did get 3, please be willing to help those out that didn't. If it becomes a super question and nobody understands that one, we can certainly talk about it tomorrow, but follow the same process up here. And then I'm going to go over to your notes. It's the same question that's in your notes. I just want to make sure that everyone sees where it is. So in your notes, same question, find the rate of change for h of x between 0 and 2. So if you haven't done this yet, make sure that you pause it and try it on your own. Turn your brain on and try it on your own. Pause the video and then come back and see how we did. Hopefully the first thing we did was identify that this is our x1 and this is our x2. And then we need to find our y1 and y2. So y1 is going to happen when we plug 0 into this equation. So I have 2 times 0 squared minus 3 times 0 plus 4. And 0 is a nice one because a lot of it's going to go away. 0 squared is 0 times 2, that's 0. Minus 3 times 0, 0. Plus 4. So y1 is 4. And y2 is going to happen when we plug in 2 to that equation. So I have 2 times 2 squared minus 3 times 2 plus 4. Again, just plugging 2 into that equation. And so I've got 2 squared, which is 4, times 2, which is 8. 3 times 2 is 6, plus 4. 8 minus 6 is 2, plus 4, which is 6. And then I need to apply this average rate of change formula we've got up here. So I'm going to take my y values and subtract them. So I'm going to do 6 minus 4. And the 6 happened when I plugged in a 2. So that 2 needs to come first. Minus 4, and that 4 happened when I plugged in a 0. So So I need to have a 0. 6 minus 4 is 2. 2 minus 0 is 2. 2 divided by 2 is 1. And that's it. So things you need to be ready to talk about tomorrow are on the first page of our notes was this question here. Please make sure that you are ready to talk about A. Well, we talked about A. B through H. Tomorrow, that will be what we start class with. For the rest of today, you've got your DOL. It is on Canvas. It is on Canvas, so it needs to be done today. Make sure you go on Canvas to do that. Second thing that's on Canvas is a discussion. So you need to post to the 6.1 discussion before the end of the day as well. It will be our participation day grade for today. So I'll be looking for this DOL to be done. I'll be looking for this discussion post to be done. And then after you do the DOL, and only after you do the DOL, homework will open for 6.1, so you can start that. If you finish all 3 of those things before the end of class, you can work on SAT practice, you can help people around you, you can organize your binders. Please make sure that you bring your binders tomorrow. We will be doing a check of our binders tomorrow, which is Friday. Okay, please post on Canvas if you have any questions. I am in the building, so I will certainly be checking these if I get a second. I don't know that will happen, but if you have questions, please post below.